Hey, hello, welcome. We're in Advanced Algebra 2 still, and we're going to start graphing exponential functions. Today the graphs start in earnest, and you can at least put away your straight edges, mostly, and you think that's great until you see why. Then you may not think that's great anymore. The basic exponential graph is something that you have graphed before, almost certainly in Algebra 1. Even my Algebra 1 did it last year, so it's strongly likely you did as well. But of course, Algebra 1 was a while ago for most of you, and everybody needs review of key ideas. So here we have example 1. We're going to graph y equals 2 to the x power. See, these exponential functions have the x in the exponent, which is why they're called exponential functions. Okay, that's fine. So let's do it. For this very first one, we'll make a t-chart. X's and Y's, so, to the 0 power is 1, to the first power is 2, to the second power is 4, third power is 8, to the fourth power is 16. I'm not going to write it, but to the fifth power would be 32. That's not going to fit. 16 itself isn't going to fit. So those are the dots for those. Now let's go backwards in time. For negative first power, it's like 1/2. So it's 0.5, because remember, negative powers are in the denominator. So negative second power is 1/4, so 0.25, and negative third power is 1/8, so 0.125, and negative fourth power is 1/16, so 0.0625. Negative fifth power is 1/32, which is, oh gosh, that's just small. These are tiny, right? These are going to 0. So if we go backwards, boom, 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 these are small numbers, so we can connect the dots. I connected them more quickly in audio than in visuals, but there we go. And you'll notice on the left it's going down to 0. In fact, over here on the t-chart I drew an arrow towards 0 to show you that. And because of that, it has something that we call an asymptote at 0, because it's getting really close. And the fun thing about an asymptote is that you say, you're not going to get there. It's getting close to 0, but it's not quite. So you have an asymptote at y equals 0. That's okay. And we'll keep kind of track of that as we go along. So that's our graph, 2 to the x. Yay! On the right, it grows really fast, but it doesn't actually have an asymptote, because you can stick any large number for x in. So the domain of these things is all real numbers. The range, in this case, is greater than 0. I'm not writing it here. It should be fairly obvious for you. Hey, look, example 2. We're going to do some things here. Now, here we have x minus 3, and that means the graph moves right 3. This is just like having minus 3, like in the parentheses for a parabola, or inside the absolute value bars. If it's inside the function, meaning inside the action of what's going on, it's a left to right switch, or shift, excuse me. And because of that, it's backwards from how it should be. But all these dots are now moved right 3. So in green, I've done the same graph, moved right 3. The asymptote doesn't change. It's still 0, because it's still going down to 0. And there you have it. For the next one, though, it's... Oh, sorry. There's our asymptote. And 0. For the next one, though, we've got minus 3. This is not in the exponent. It's outside the exponent. It's hanging off on the end. So the graph moves down 3. This is probably easier for most people to stomach. You've seen this again with parabolas and absolute value v's and all sorts of things. So you take all those dots and you move them down 3. So again, starting with the red graph, the original y equals 2 to the x graph, they're all moved down 3. So the asymptote now is negative 3, because it moved up or down. So moving up or down will change the asymptote, and I think we'll see later on that that is the only thing that will change the asymptote. All right, there's a little basic graph of 2 to the x. We've got a couple shifts happening there. Good times. Here we have another one. We have 1/2 to the x. This one is also worth making a t-chart for. So x is 0, it's 1. And if it's 1/2 to the 1, it's 0.5. If it's 1/2 squared, it's 1/4. If it's 1/2 cubed, it's 1/8. And if it's 1/2 to the 4th, it's 1/16. And then if it's 1/2 to the 5th, it's even smaller. I'm not even going to do it. There we go. And then, how about some negative numbers? Oh, here we go. Okay, so -1, ooh, it's 2, because remember, they're upside down for negative exponents. So for the -2, it's 4. For negative third power, it's 8. Boom, 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 growing up on the left. And zoom. And we still have an asymptote at y equals 0. Oh. Okay. So then, we've got some shifts to have happen here. So here we got first one here, which is 3 times 1/2 to the x. So what we're going to do here, and I kind of moved it around because just so there's room, but each y value is going to multiply by 3. So 3 times. And so basically what that means is it's vertically pulled by 3. This is basically kind of changing the slope, but again, it doesn't really have a slope because it's not a line, but it's the same basic idea. So it's a vertical stretch by 3. Now, here I need you to bear with me just slightly. So if we go back to the other thing, the other graph, and each of the values is multiplied by 3. So at 0, it's pretty easy. You multiply it by 3 and you get yourself a dot, you know. And at -1, you'd multiply that y value by 3, and since it was 2 times 3 is 6, and at -2, the y value was 4, so you multiply it by 3 and you end up at 12, which, you know, you're not really obligated to graph, but I want you to see, okay, it's up there at 12, because it's thrice as much. Okay, at 1, it was 1/2, so you multiply it by 3, it becomes 1.5. That's an ugly dot. At 2, it was 1/4. Yeah, so it was 1/4, so you multiply by 3, you get 3/4, and at 3, it was 1/8. You multiply by 3, you get 3/8, which is about 1/2, a little bit less. At 4 is 1/16. You multiply by 3 is 3/16, which is, well, it's, you know, almost 1/4. And so, boom. And so then, zoom. And over here on the left, oops, that's ugly. I'm going to try that again. Boom. And there you've got your asymptotic graph. I mean, you've got the graph, right? It's 3 times as much as it used to be. That's good stuff. I see I failed. I'm going to redo some of this, and this is embarrassing, and will live on in infamy forever with the YouTube. But you can see here, when I took my very first point, and I multiplied by 3, I ended up at 4, which is extra awkward. But everything else I said is true, so hopefully you didn't erase everything in a fit of rage. Although no one would fault you if you did. Those are the dots. And now if you multiply by 3, boom, and then, okay, that's just wrong. Boom, and now you've got your graph. It looks a little bit better, although the turn there at -1,6 is a little ugly, but that'll do. Okay. So moving on here, we'll go back to the thing where we were, and we had that, and so it's vertical stretch by 3. So then now, for negative times 1/2 to the x, each y value is multiplied by -1, right? So it's the opposite. Okay, so what this is going to mean for the graph is that it's flipped over the x-axis. This is a little tricky. So let's go back and look at it. Flipped over the x-axis. Ooh, excuse me about that. Flipped over the x-axis. So that was in green. So we'll take the red graph as our basic, and we're going to flip it over the x-axis. Each point will now be the opposite of what it used to be. The y values will be opposite. And so instead of 2, it's -2. And instead of 4, it's -4. Instead of 8, it's -8. And those are our dots. And we're like, That's not quite right. We can do better. Maybe not. Let's see here. Try again. Boom. Okay, so now it's flipped over the y-axis. Excuse me, flipped over the x-axis. So it's upside down compared to before. The y values are opposite. Interesting. Notice the asymptote for all three of these graphs is still at 0 because it hasn't actually moved the graph up or down. This is mildly amusing, at least to me. Boom, 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 boom. Here we go. Okay, now, if it's 1/2 to the negative x, see now the negative sign is in the x, this way the x values, because it's inside the function, changing the x's, the x values are opposites, and what's going to happen here is it's flipped over the y-axis. Now this is crazy talk here, so you've got to bear with me. This is actually quite exciting. We'll go back to the other thing, and we're going to take, again, the original red graph. There's a lot to look at here at this point, but the original red graph flipped over the y-axis because the x is negative, so all the x values are flipped compared to the original red graph. To infinity. Okay. Hey, the asymptote hasn't changed. Still at 0. So let's go to oops, sorry. Super special fun bonus. Must be visually disconcerting. I'm sorry. This purple one, which was 1/2 to the negative x, is the same as 2 to the x was, like the example 1, the very first one. Because negative exponent flips it upside down. I tell you, this brilliance here, not mine, just the math. Anyway, so that's interesting. Okay, we'll move on. Too much at once. Okay, so now, here's complicated, going to throw everything together for you. So I'm going to graph this step by step. In its most basic form, so this is in order because I'm going to make it step by step in complication. In its most basic form, it's y equals 3 to the x. So y equals 3 to the x is this graph here. You got powers of 3 going on, and then you got negative powers of 3, which are boring. They go to 0. They all go to 0. Okay? Now, the next thing in this complicated equation, for example 5, is that plus 1. So, okay, that's graph 1 to show you, right? But the next thing is x plus 1. So this moves it left 1. So, okay, look at that, left 1. So here we go. Take each of those points and move them left 1. Okay, there's graph 2. All right, now, the next thing as we build up this equation would be adding in that 2, or actually, multiplying in that 2. I'm going to change colors because too many graphs at once, kind of crazy. So when we multiply by 2, that's a vertical pull of 2. That means each of the y values is twice as big as they used to be. So vertical stretch by 2. So taking this time we're taking graph 2 because we're building off of that. And I'm doubling all the y values. Okay, that's graph 3. Now the next thing was that negative sign. So we're going to multiply by negative 1, or rather change the 2 into a negative 2. Same thing. So this is that flip over the x-axis. Because it's a funny story, right? It changes the y values, changes the outputs. And so it flips over the x-axis. Axes are annoying. Okay, so here we go, and zoom, zoom. So the same point values as graph 3, but now negative graph values. And then the last one is this plus 5 business at the end. So that will shift the entire graph up 5. Moves up 5. Notice I wrote move instead of shift because once on a quiz I forgot the F in the word shift, and that was inconvenient. Okay, so then zoom. Okay, so again, each of those points is moved up 5. And there's a lot of points there, folks. When I say each of those points, I mean from the graph before, right? So looking at graph 4, which is the blue one headed down, you move each of them up 5. And there you've got the final graph. And finally, I'd like to point out that the asymptote at the very end is the line y equals 5. The only thing that changes the asymptote is a vertical shift, right? Adding or subtracting a number on the very end. That's it. Okay, that's all we got for today. It doesn't say it on the notes, but the assignment in class next time will be a worksheet. We got these graphs. They're quite exciting in the most awesome of ways. Thank you for watching, and have a great day.